Okay, so what are systems of inequalities? Well, very similar to systems of equations, but we're talking about inequalities now, and we've looked at inequalities before. These less than, greater than, equal to symbols. So basically, these are all involving graphing. We can't do anything but graph these. So before we were allowed to, with equations, we were allowed to solve using substitution, elimination, or graphing. But right now, this is the only way we can do it is with graphing. And so these look and smell like slope-intercept form. And so what we want to do is we want to graph them just like we would slope-intercept form. So let's graph the top one. The top equation is going to have to start, inequality is going to have to start at 2, right? So that inequality starts at 2. The slope is 3. So that means I'm going to go up 1, 2, 3 over 1. I'm going to do that 2 times. Just so I can kind of see like what's going to happen to the graph. Now, don't connect those dots until you look at this. See, that symbol tells us something, and we should recall what that symbol means. Back when we were looking at solving inequalities and we had to graph these things, when we had a line underneath, that meant equal to, which meant a solid dot, if you remember. So when we're talking about solid for graphing purposes, we're talking about a solid line. So we're going to go ahead and graph a solid line, so we can connect all of those. But if you look down here, when we get to this next one, well, this one here, it doesn't have that equals to sign underneath. So we're going to take a look at it in a second. Let's go ahead and graph the second one. The second one starts at -4, 1, 2, 3, 4, and it goes up 2 over 3. Okay, now, because this doesn't have a line underneath it, that's going to mean it's dotted. And it doesn't matter the direction that these things are pointing, it matters what they look like. So we're going to go ahead and dot a line. Now, listen, the thing about systems of inequalities is that anytime I'm going to graph these, I have to shade some type of region here, okay? And so when I look at these two lines, I'm also going to look at these symbols and see which direction they're pointing, okay? Since this top one is appearing that it's pointing towards the 3x plus 2, that tells us that we're going to have to shade everything that's below this line. Because see, inequalities mean that I have a bunch of values that will work. So here's my original line. I'm going to have to shade with some type of pencil everything below that line. Okay, so I'm just shading everything below. Now this does continue forever, but I just want to go ahead and just take a piece of the graph. I don't need the whole thing. I don't want to keep shading forever and ever and ever. I just want to go ahead and go below this line and then just kind of drag it out to where my edge of my graph is. Okay, so I've taken care of that because this tells me below. So maybe we want to take note of that. If I see something like this or like this, that means shade below. Okay, you want to shade below the line. But if it looks like this, then I want to shade above. Okay, so let's look at the next one. Down there at the bottom, I have to shade above this line because it's telling me that it's pointing towards the y, and therefore I have to shade above it. Here's my dotted line, so I'm going to take a different color and I'm going to shade above that line. You may be like, well, why do I need to do this? Well, I'll show you here in a second. So after I shade all of this part right here, it tells me some stuff. So before, when we talked about equations, the solution was where these things intersected, but these aren't intersecting. But they are overlapping in terms of a shaded region. And you can see it. It's a whole different weird color, right? So this right here is my answer, okay? It's my answer to this system. Everything in purple only is an answer to just that inequality, and everything in orange only is just an answer to that inequality. but where they overlap is the actual solution. And so what we're referring to is if I pick any point that is inside of this region, it will work for both of these inequalities. And what I mean by work, it will make sense. For example, if I pick the point 2, 0, and I plug it in for x and y in both of these, it will be true statements that result from it. And so it's important that you realize that this is not going to be just one solid solution. Instead, it's going to be an infinite amount of solutions. Okay, they're going to go on forever, but are contained within a region here. Okay.